In this video, I'm going to solve a question about the two dependent samples, the matched pairs. The following data lists the ages of a random selection of the actresses when they won an award in the category of the best actress, along with the ages of the actors when they won in the category of the best actor. The ages are matched according to the year that the awards were presented. Now, complete part A and B below here. So we have the actress, the years, and the actor with the years. Okay, so this is the dependent samples because the samples values are matched together. Now, part A, use the sample data with the alpha of 0.05 or 0.05 significant level. This is the alpha. To test the claim that for the population of the ages of the best actresses and the best actors, the differences have a mean less than 0, indicating that the best actresses are generally younger than the best actors. Now, in this example, UD is the mean value of the differences D for the population of all the pairs of the data, where each individual difference D is defined as the actress age minus the actor's age. And what are the null and the alternative hypotheses for the hypothesis test? So first thing is we need to check the requirements. This is the sample data that are dependent because they are the matched pairs. So that is correct. The samples are simple random sample, which is also true. Now, either or both of the following conditions is satisfied. The number of the pairs of the sample data is large enough, bigger than 30, or the pairs of values have differences that are from a population having a distribution that is approximately normal. So if we see that there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 pairs. That is less than 30. So we need to make sure that the differences from the pair they are from a population having a distribution that is approximately normal. And if you do the normal probability plot, you should see that it follows a normal curve. Okay, so now the first thing we need to do is we need to determine the null hypothesis and the alternative hypothesis. Now in this case, the null hypothesis is always the mean of the mu D, the mean value of the differences of D of the population of all the pairs. We always assume this is equal to 0 initially. And now we want to compare the mean. You want to compare what? We want to compare, we want to test the claim that the population ages of the best actresses and the best actors, the differences have a mean less than 0. So less than 0 is what we are looking to do the testing. So you want to test the mean to be less than 0, the mean value of the differences, the mean of the differences less than 0. And this is the claim. And because this is the arrow is pointing to the left, we know that this is the left tail case. Left tails. Alright, so we know alpha is 0.05, and the next thing is we need to find the test statistic. The test statistics. And the test statistic is given by the formula d bar over SD divided by the square root of n. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n in this case equal to 10. Now the next thing is we need to find the differences, d. Okay, so d is defined as the axis h minus the actors h. So you take 29, right, for each of them. 29 minus 64, 27 minus 36, 29 minus 39. You do all the subtraction for all the columns. And these are the differences between the years of the actress and the actors. Okay, so those are the d value. Now the d with the little bar on the top, that is the mean of all of these values right here. And then the SD, this is the standard deviation of all the value you just found right here. So to find these two values, I can just use the TI-84 to do that. First thing is I need to list these values into a list. So I go to Start, Edit, and then I input the last row. This is negative 35. I input everything. Oops. I input everything on the list L1, and then negative 10, another negative 10s, and then 7s, and then negative 9, negative 31, negative 5, negative 2, and negative 5. So these are the value. And now you want to go to Start, go to Calculation, choose one variable statistic, and then you want to calculate that. So the mean value, which is the mean value of all the d, the differences, which is d bar, and that is negative 10.9. Negative 10.9. And then SD is the standard deviation, which is right here. S is a standard deviation of the data, 12.75 if you round it, 12.75. And then the square root of n, we have 10 pairs, so the total is 10. Now we can perform this calculations. So negative 10.9 divided by 12.75 over the square root of 10. And that would give me negative 2.70. Negative 2.70 is the test statistics. Now we need to find a p-value. Right, how do I find the p-value? Well, I know that I have to draw the curve and negative, so I'm putting it right here, the test statistic negative 2.70, and this is the left tail. This is the left tail. So I want to find all the area to the left, right? The area is the p-value, which is the p-value. And we know that we are using the t, student t distribution. So to find the p-value, I just use the TCDF functions. And I know that this is the left tail, so I want all the way from the left. So I put a very negative number, and then I go up to negative 2.70, and the degree of freedom 10 minus 1, n minus 1 is the degree of freedom. And if I use this functions, second distributions, TCDF go up to negative 2.70. Degree freedom 10 minus 1, which is 9, and that will give me 0.012. 0.012, and our alpha is 0.05. Alpha is 0.05 right here. So 0.012 is less than 0.05, which is alpha. So if it's less than alpha, what is the conclusion? If the p-value is less than alpha, we reject the null hypothesis. Reject the null hypothesis. If we reject the null hypothesis, that means we have enough evidence to support the claim. We have enough evidence to support the claim, which is the population of the ages of the best actresses and the best actors. The differences have a mean less than 0. So that indicates the best actresses are generally younger than the best actor. So we support this claim. So since the p-value is less than or equal to the significant level, reject the null hypothesis, and there is sufficient evidence to support the claim that actresses are generally younger when they won the award than the actors. So that is part A. Now part B, construct the confidence interval that could be used for the hypothesis test. That's right in part A. And what feature of the confidence interval leads to the same conclusion reached in part A? So this is another approach we are using to do the testing by constructing the confidence interval. So there are the formula for the lower bound and the upper bound. So we know that the 1 minus alpha 100% confidence interval for the differences, the mu d, the mean of the differences, has the lower bound of the formula d bar minus t alpha over 2 and then sd divided by square root of n. That is the lower bound. The upper bound is found by the formula d bar, the minus become plus, t alpha over 2 and then sd the square root of n. Alright, so the alpha in our case was alpha right here, 0.05. And again, this is the one tail test only, right? This is the one tail. Therefore, you do not divide alpha by 2. Keep alpha as 0.05 because this is one tail. And to find the t alpha over 2 or the critical value, right? This is just a general formula for two tails, but we are just looking for the critical value, but do not divide alpha over 2 here because this is one tails case. So we know that the area is 0.05 to the right of that critical value. So to find the area to the left, we simply take 1 subtract 0.05, and I need to find this value right here, which I can use the inverse t functions on my TI-84, and I put the left area as the argument, and comma, the degree freedom is 10 minus 1, and that will give me 1.833, and I plug that in right here and with the other values, and I make the calculation. I got lower bound to be minus 18.29, and then I add the same thing, just change the minus to the plus, and I do the calculation here. I get the upper bound to be minus 3.51. So just a quick review of how to use the invert t functions. We use the second distribution and then go to invert t, and the area is the one on the left side, 1 minus 0.05 of that critical value, and then the degree of freedom is 10 minus 1, and that will give you 1.833. Again, we don't divide alpha by 2 if that is the one tail only. Now, because the confidence interval contains only the negative number, therefore we reject the null hypothesis. Okay? We reject the null hypothesis. And that is the same conclusion as we did for the p-value. And the reason that we reject the null hypothesis because it only has the negative value, right? It does not have the 0. Therefore, the mean of the difference, you don't support this one because it does not include 0. It only includes the negative value. That's why we have enough evidence to support the alternative hypothesis, and therefore we reject the null hypothesis because it does not include 0. It's only negative, from negative 18 to negative 3 only, so it does not include 0.